We're on the back here now on page 38 of our Chapter 4 packet, and we need to finish up our lab by doing the analysis. Here's where we're going to crunch the numbers. So I circled here the acceleration formula, which is VF minus VI. F stands for final and I stands for initial. So our final speed minus our initial speed, we take that quantity. So in other words, we take the difference in our calculator, hit enter, and then divide it over the change in time. Now typically we start counting time at 0, so you'll often just see time on the bottom, but really it's the final time minus the initial time, as we'll use here. So I tried to put the slope formula next to the acceleration formula to show you that it is the same thing. The final speed is like your y2 coordinate, and your initial speed is your y1 coordinate. And then you take away your initial time from your final time. So if we look at what we're looking for here in initial and final times, and we compare that to our data table, and we plug these numbers into the slope formula, I think it's helpful to just look at the numbers that we need. So in this first analysis question here, it's asking us to analyze acceleration from 0 to 3 seconds, which would just be this bit of data. If we do our final speed minus our initial speed for those coordinates for 0 to 3 seconds, think about the time. Let's start there. If we put that on the bottom as our x2 and x1, our final speed is going to be our x2. So 3 minus 0, 0 being our x1, and our speed coordinates that go with those. So the speed coordinate that goes with 3 is 30. Would be our y2, and the speed coordinate that goes with 0 is 0, would be our y1. So if we take the quantity of 30 minus 0 and divide that over 3 minus 0, we of course get a value of 10. Once we put in the units for acceleration, that's going to be in meters per second squared, or meters per second, because again, we're looking at change in speed over change in time.